In this video, we're going to take a look at polynomials. You did this a little bit in Algebra 1, so we're just going to expand on that idea. So in this particular section, we're just going to talk about how to simplify polynomials, how to add polynomials together, and subtract polynomials. All right, so now that we've spent some time studying functions, just in general, what a function is, the graph of a function, we've looked at linear functions. We're going to, in the coming sections, we're going to begin studying specific types of functions. And one specific type of function is a polynomial function. But before we can study polynomial functions, we need to make sure we understand just what a polynomial in general is. So that's what this section is going to start us on, is just what a polynomial is in general. So quite a bit of vocab that's going to go with this. So a constant, which we've talked about earlier this year, a constant is just a specific number. So it's not a variable, it's a specific number. So 3 or negative 2/5 or 0 or square root of 5 or any real number that you can think of, a specific number we just call a constant. Well, you're going to hear the word monomial a lot. A monomial is a constant. So any constant you can think of, we could also call a monomial. Those are kind of boring though. A monomial can also be a variable, or it could be the product of a constant and one or more variables. Now, something we have to remember is if you have variables, then those variables must have non-negative integer exponents. So it could have 0 as an exponent. It could have 1, 2, 3, 4, 25, 1,060, any non-negative integer exponent. So it cannot have a fraction for an exponent. It cannot have a negative number for an exponent. It can't have a decimal for an exponent. It has to have a non-negative integer exponent. So for example, negative 10 would be a monomial because it's a constant. X would be a monomial because it's a variable. 4y would be an example of a monomial because it's the product of a constant and a variable. Negative 6x squared y to the 5th would also be an example of a monomial because again it's the product of a constant and a couple variables, and their exponents are non-negative integers. Or something like 1/2 a times b, where a and b are the variables. So those are examples of monomials. Next two things, coefficient. If we refer to a coefficient, that is the numerical factor in a monomial. So for example, 4xy is a monomial. It's the product of a constant and one or more variables. So this is a monomial, and the numerical part, the 4, that's the coefficient. So that has a coefficient of 4. It's the number out front. Negative x to the 6th is a monomial, and it has a coefficient of negative 1, because negative 1 is what's sitting out in front of the variables. Well, we can also refer to the degree of the variable or variables in a monomial. And when we refer to the degree of one of the variables in a monomial, it's the number of times the variable occurs as a factor in the monomial, which sounds scary, but it's not too bad. So for example, 6x to the 3rd, we would say that x, which is the variable, has a degree of 3. And we know that because x to the 3rd is the same thing as x times x times x. So if you go back and look at the definition, it's the number of times the variable occurs as a factor in the monomial. Well, since x to the 3rd is x times x times x, that's 3 x's, so we have a degree of 3. Another example, 4xy to the 5th. That's a monomial. It's got two variables though, x and y. Well, x, since it's raised to the first power, there's only one x, so x has a degree of 1. but y to the fifth would be 5 y's. So if we wrote that out, it'd be y times y times y times y times y. It'd be 5 of them, so y has degree 5. So x is degree 1, y would be degree 5 in that example. Well, the entire monomial, not just the variables, but the entire monomial can have its own degree, and does have its own degree. So the degree of an entire monomial is the sum of the degrees of the variables in the monomial. If it's just a constant, no variable, then we'd say the degree is 0, unless the constant is actually 0 itself, then it actually has no degree. But that's pretty boring, and we don't worry about it too often. So for example, let's say you have the monomial 1/2 x squared y to the third. Well, as we just talked about, x has degree 2, y has degree 3. However, the entire monomial, you add those degrees together to get the degree of the whole monomial. So 2 plus 3 will give us 5. So that entire monomial has degree 5. Another example, negative 4y. Since y is raised to the first, then, and that's the only variable, then that monomial has a degree of 1. Well, we're going to spend a lot of time worried about similar or like monomials, especially when we simplify. So when we refer to similar monomials or like monomials, we're talking about monomials that are identical, except for maybe their coefficients will be different. But other than that, they have to be identical. So for example, 4xy squared and negative 2xy squared. They're identical except for their coefficients. So 4 and negative 2 are different, but the variables are exactly the same. It's x to the first, y squared, x to the first, y squared. So those are similar. On the other hand, 15x to the third, y to the first, that's a monomial, and 4x to the first, y to the third are not similar. They're not similar because in the first one, x is degree 3, in the second one, x is degree 1. So they're not identical. The variables and their exponents have to be identical. The coefficients can be different, but the variables and their exponents have to be identical. All right, so what is a polynomial? Well, mono means one, and poly means many. So a polynomial is a monomial or a sum of monomials. The monomials that are in a polynomial are called terms. So for example, 2x squared plus 7. 2x squared is a monomial and 7 is a monomial. When you add them together, you get a polynomial. 1/4 x to the third minus 7x squared plus 11. 1/4 x to the third is a monomial. Negative 7x squared is a monomial, and 11 is a monomial. But when you add them together, remember, subtraction technically is the same thing as addition, because you can just change it to plus the opposite, or plus a negative. So when we add those together, we get a polynomial. Well, a polynomial can just be one monomial. So like 14 is a monomial, so it's a monomial and at the same time it's a polynomial. And you can have lots of variables in your polynomial. So 2xy squared minus y plus 1, that would be a polynomial because 2xy squared is a monomial, negative y is a monomial, and 1 is a monomial. And then when you add them together, you get a polynomial. Now, when you're talking about polynomials, when you want to refer to an individual monomial, since that word's kind of cumbersome, we also call them terms. So 2x squared is one term, 7 is a term, 1/4 x cubed would be the one term. Just a little bit easier to call it a term than keep saying the word monomial over and over. Well, one of the things we're going to want to be able to do is simplify polynomials. So what would it mean to be simplified? Well, a polynomial that's simplified is a polynomial in which no two terms are similar. And then terms are put in order of decreasing degree of one of the variables. So no terms can be similar, and then the terms are put in order by decreasing degree of one of the variables. So for example, 6x to the fifth, negative 7x to the fourth, plus 13x minus 3/4. So that's a polynomial. Well, you have degree 5, degree 4, degree 1, degree 0, so none of them are similar, and the degrees are in decreasing order, so 5, 4, 1, 0. So we would say that's simplified. Here's an example of one that's not. So if you have 15x to the first minus x to the fourth plus 11x plus 6.2, that's not simplified. The main reason it's not simplified is 15x and 11x are similar because they're both x to the first. So we technically should do something about that, and that's what we're going to do here next. Since those are similar, this is not simplified yet. Not only that, the degrees of the terms or monomials are not in decreasing order. So the x to the fourth should be out front, and then the x's should be next, and then the constant should be last. So, all right, last little bit of vocab. The entire polynomial has its own degree. So the entire polynomial has its own degree. It's the greatest of the degrees of its terms after you simplify. So for example, x to the fourth minus 2x squared y to the fifth plus 16y minus 12. So there's no similar terms. The degrees are in decreasing order according to the x variable in this case. So x to the fourth, x squared, and then no more x's. And the biggest degree of one of its terms is 7. This first term has degree 4. This term has degree 2 plus 5, which is 7. This term has degree 1, and this term has degree 0. So the biggest one is degree 7. In this next example, 21x to the 10th minus x to the 4th plus 13, it's simplified because there's no similar terms, and the biggest degree of one of its terms is 10. So the whole polynomial is degree 10. Let's say you have a pretty simple polynomial like y minus 3. Well, y and 3 are not similar, and the biggest degree on one of the variables is 1, so y to the first, so it's degree 1. So individual variables have their own degree, monomials have their own degree, and the polynomial itself has its own degree. So that's one of the things you're going to want to practice with is, which degree are we interested in at any given time. All right, so let's practice combining polynomials, adding, subtracting, and then simplifying them. You don't actually have to learn anything new here. We're just going to use the same properties we've been using in the course up until this point. So, for example, let's subtract the second one from the first and then simplify and then give the degree of the result. So here's a polynomial, here's another polynomial, and we're supposed to subtract the second one from the first. So we'll take the first polynomial and subtract the second polynomial from it. Now be careful. We want to subtract the entire polynomial from the first one. Mathematically, that's going to require parentheses around that second polynomial. That way we distribute the negative. We want to make sure we're subtracting the entire polynomial, not just that front term, but the entire polynomial. So let's go ahead and distribute that negative. So this will be 2x squared minus 3x plus 5 minus x cubed plus 5x squared minus 2x plus 5. And then now what we want to do is we want to put all the similar terms together. So one of the things that helps when you're first doing this is literally rearranging all the terms so the similar terms are next to each other. So if you go through and look, there's only one term that has an x cubed, an x with a degree 3. So I'm going to write that one first. And there are two terms that have an x squared. So there's this first one 2x squared, but then later down the line we have a 5x squared. So I'm going to write those two next to each other. Then I have a negative 3x and a negative 2x. So those are similar. And then I have a positive 5 and another positive 5. So those are similar. Now that they're all the similar terms are next to each other, I can go ahead and combine them. So just like we have been, you can add or subtract similar terms or similar monomials. So I'll have negative x to the third, and then if I have 2x squareds plus 5x squareds, I have 7 of those. Negative 3x minus another 2x will be minus 5x, and then 5 plus 5 is 10. So this would be a simplified polynomial because there are no similar terms, and I go x to the third, x squared, x to the first, and then degree 0. There's no x in the last one. And we need to give the degree of that polynomial. So that polynomial would be degree 3 because it's the biggest degree of any of its terms. So it'd be degree 3. All right, let's try another one. So let's add these two polynomials, simplify it, and give the degree of what we get. So we'll take 2x squared minus 3x plus 5, and we'll add to it the second one, x to the third minus 5x squared plus 2x minus 5. I put the second polynomial in parentheses again, but this time, since I'm adding them, there's just a positive 1 out in front of the parentheses. So when I distribute a positive 1, it doesn't really change anything. So when you add polynomials, the parentheses are optional. Without them, you would get the same result. So we're going to do the same thing we just did. This would equal, let's go ahead and just rearrange everything so all the similar terms are next to each other. So it'd be x to the third, and then we'd have a 2x squared and a negative 5x squared. We'd have a negative 3x and a 2x, and then we'd have a positive 5 and a negative 5. So we have a 2x squared and a negative 5x squared. We also have a negative 3x and a 2x, and then we have a positive 5 and a negative 5. And then we can go ahead and combine the like terms. So it would be x cubed, and then a negative 3x squared, then a negative x, and 5 minus 5 is 0. Those are additive inverses. So there's nothing else to combine. All the similar terms are gone. I have an x cubed, an x squared, and x. And then the degree of that polynomial, well, the biggest degree of any of its terms is 3. So it would be the degree 3. All right, one more. Let's simplify this polynomial and give the degree of the result. So let's look. We have x to the first, y squared, z cubed. And then the next one is x to the first, y squared, z cubed. So those are similar. The only difference is 7 and negative 4. So if I have 7 of them and then I lose 4 of them, I have 3 of those. And then the next term is x squared, y, z squared. Well, that's not the same as the first two. And then x to the first, y squared, z cubed, that is the same as the first two. So I'm going to write that next to, we like to write the similar ones right next to each other. And then there was nothing similar to 2x squared, y to the first, z squared. That's the only one that has those variables with those exponents. Well, if I have 3 of these and I subtract 3 of them, then I have 0 of those. So I have 0 of these. And 0 times anything is just 0. So you end up with 2x squared y z squared. So this original polynomial equaled this simplified polynomial, which equaled this simplified polynomial, or more, I should say more simplified. It's not all the way simplified to the very end. So right down here. And the degree of the result, well, I have an x squared, I have a y to the first, and a z squared. So I add the exponents. I add the degrees of each variable. So it would be 2 plus 1 plus 2. This would be degree 5.